Deep space may be the final frontier, but we already know more about the orbits of stars around the supermassive black hole at the center of the Milky Way than we do about the behavior of the colossal squid and other creatures that live deep in the oceans here at home. In fact, water deeper than a kilometer covers more than 60% of the planet, which means we know very little about the most common environment on Earth. There, creatures odd and tasty have learned to survive in constant darkness, near freezing cold, and extreme pressure, all of which mean there's very little available oxygen, food, or companionship. Surviving in this environment requires some extraordinary adjustments. 1,000 meters down, the pressure is over 100 times what we experience at the surface, or enough to compress the air in a soccer ball to the size of a ping pong ball and a half. Unlike most other fish, the ones that live in these depths don't have gas-filled cavities like swim bladders that would collapse under the extreme pressure. In fact, super deep-water fish often have minimal skeletons and jelly-like flesh because the only way to combat the extreme pressure of deep water is to have water as your structural support. Until recently, we left deep-water fish alone, but as coastal fisheries became depleted, fishermen went further out to sea where they found a lot of large, tasty fish. As they caught and depleted the ones near the surface, they simply fished deeper. Fishing deep is a game changer, though. Because these fish are remarkably well adapted to the pressures of the depths, they're remarkably unfit to deal with the pressures of modern fishing. Cold temperatures and lack of food means that fewer fish live in the deep, and those that do grow slowly, which means they also reproduce slowly. For example, the orange roughy live out their long lives, often more than a century, 500 to 1,500 meters below the ocean's surface. At their best, they can only replace 6% of their population each year, while shallow water fish like cod, mackerel, and herring replace half of their entire population in the same time, assuming we don't fish them. When commercial fishing for orange roughy took off in the 1980s, the catch was astoundingly good, but within 25 years, most nets came up empty. If you think about it, we're basically mining the oceans, which means it's rough going both for orange roughy and other slow-growing but delicious denizens of the deep, as well as for the fishermen whose lives depend on them. If we could only learn to harvest fish at the same rate as they replace themselves, it would benefit fish, fishermen, and our future cuisine. Because while we can always mine asteroids for minerals and precious metals, as far as we know, there aren't any fish in space. So we should probably be protective of the ones that we have here.